Hi everyone, today we will discuss problems in current electricity. So here you can see this question. The potential difference across the terminals of a storage battery is 10 volt in a closed circuit. If the external resistance is increased by 1 ohm, the potential difference increases by 1 volt. A further increase in the external resistance of 3 ohm produces a further increase of 2 volt in the potential difference. What is the EMF and internal resistance small r of the battery? So let us consider this external resistance is R, EMF of the cell is E, and internal resistance of the cell is small r. So we have this EMF as E, internal resistance is small r, and external resistance capital R. The current passing through this circuit, let us say it is I. When it is a closed circuit, so the current will be passing, suppose, from the higher potential towards the lower potential, let us say it is I. Now the question says, so the potential difference across the terminal of the storage of the battery. So across the terminal of the cell, it is already given as 10 volt. So across these 2 points, yani the higher potential, this is your higher potential and this is the lower potential. So across the terminal of the cell, yani between these two, higher and lower, or between anode and cathode, or between this point and this point, it is 10 volt. Okay, so this terminal voltage across the cell, it is equal to what? Let us say if it is suppose V, then V it will be equal to I into small r, where small r is the internal resistance of the cell. The potential difference across the cell, it is just because of its own internal resistance. So we have V is equal to I into this r. Now, so this relation is known to us and V it is given. It means this is equal to 10. This is already given here. Now, if the external resistance is increased by 1 ohm, this is now increased by 1 ohm, the potential difference increases by 1 volt. So if it is increased by 1 ohm, so the total resistance, now it becomes what? R plus 1 here and plus this small r. So the total resistance or the equivalent resistance, if it is suppose R dash, then this R dash is equal to R plus this one increase plus this small r. And initially it was capital R plus small r, now it is increased by 1, so the equivalent resistance of the circuit, it becomes your R plus 1 plus this R dash. Now, so the external resistance is increased by 1 ohm, the potential difference increases by 1 volt. So now if the potential difference is suppose V dash, the increased potential difference, then it will be equal to what? I dash into small r. Small r will remain same, and the potential difference across the cell, again it depends on small r, but this current I will change because the total resistance has changed, so current I will change. So let us say it is I dash r. So V dash equal to I dash into this r. Now I dash into r, so this is again given as how much? It increases by 1 volt, means this becomes 11. So from here you can say I, it is equal to 10 by small r, and from here you can say I dash is equal to 11 by small r. 11 by small r. I dash is equal to, this will be your I dash, so I dash is equal to 11 by r. Okay. Now again a further increase in the external resistance of 3 ohm produces a further increase 2 volt in the potential difference. So further increase by how much? 3 ohm. So further increase by 3 ohm, so that R double dash, in that case this will become how much? R plus 1 plus 3, means R plus 1 plus 3 plus small r. Further increase of 2 volt in the potential difference. So again the potential difference, it becomes how much? V double dash, which becomes, this was 11, further increase by how much? 2 volt. So that is 11 plus 2 means 13, and that is equal to your again I double dash into small r. Again this small r remains same. The current will change because the total resistance has changed. So this is equal to your I double dash into small r. So from here again we can calculate this I double dash is equal to how much? V double dash divided by small r, and V double dash is how much? 13 upon this r. So we have how many equations? So we have first equation, we have second equation, and we have third equation. Three equations are there. I double dash 13 by r, I dash 11 by r, and I is equal to 10 upon this r. Okay. Now, what is the EMF and internal resistance R of the battery? So we have to now relate this. Now if you calculate this I, and suppose internal resistance was small r and EMF is E, so I, it is equal to how much? This I here, if you calculate, so if you calculate this I in the first case, so that I, it will be equal to how much? I, we can write it as I into small r plus I into capital R, that is equal to your EMF. I into small r plus I into capital R, that is equal to EMF of the cell, so it is equal to capital A. Similarly, in the second case, we can write I dash, this I dash again into small r plus I dash into capital R, and capital R now becomes how much? R plus 1. So plus this R plus 1, and again that is equal to E. In the third, you will get I double dash. So I double dash into this small r plus again I double dash. Now the resistance has become how much? R plus 4, further increased by 3. So R plus 4, and again it is equal to your how much? This E. Now see, we have this equation, we have this equation, we have this equation, and at the same time you have this, we have this, and we have this relation. Now simplifying all that, we will be able to calculate this E as well as the small r. We can calculate this E and small, because capital R, there are three unknowns. Capital R is unknown, E is unknown, and small r is unknown. So we need three equations. Now you have these three equations. Out of that, I dash and I double dash, it is already there in terms of small r. So we can replace this I dash and I double dash in terms of small r. So once this I and I double dash and I double dash is replaced by small r, so there will be two unknowns only, small r, three unknowns, small r, capital R, and E. Simplifying these three equations, we will be able to calculate E, capital R, as well as small r, because including this I dash and I double dash, there becomes 6 unknowns. But this I dash and I double dash, it can be replaced in terms of this R. So once it is replaced in terms of R, that you can see here it is R only, here also it is R, small r, and here also it is small r. So how many unknowns will remain once this I dash and I double dash is replaced? Only 3, capital R, small r, and capital E. 3 unknowns, 3 equations. Simplifying, you will be able to calculate the required quantity. So that way we can do it. Now just using this concept, this is the basic concept. Okay, using this concept you can have a solution. So here you can see this E upon V, it is equal to R plus small r upon capital R. This relation directly it is written on the basis of the equations that we have just discussed. So from here you are getting this. So V, it was already given, that was 10. Again E upon 10 plus 1, because the potential has increased by 1. So it is 1 plus small r upon resistance was increased by 1. So again you have this relation. Again E upon further increase of 2. So 10 plus 1 plus 2, that is equal to 1 plus r. Here further increase of 3. So r plus 1 plus 3. Now simplifying, you will get this. So here directly we have used that relation, but all the equation that we have just now discussed, that is the basis of these equations. So when you eliminate the terms, and you will be able to get the terms in terms of capital E, small r, and capital R, and from there you can calculate all the required quantities. Now let us see this question. In the circuit shown on the right side, calculate the effective resistance capital R of the combination, the currents I1, I2 and I3. So we have this 16 ohm here, 12 ohm here and 8 ohm here. Currents are suppose I1, I2 and I3, because if the total current is suppose 78 ampere which is given, so once this current comes here, it will be branched in all possible directions. So here some current I1 this side, I2 this side and I3 this side. Okay, so now you have to calculate the equivalent resistance. Now all these three resistances are in parallel. So as far as equivalent of this it is concerned, you can simply use 1 upon R is equal to 1 upon R1 plus 1 upon R2 and plus this 1 upon R3. So just using this relation you can calculate this capital R, that is equivalent of the resistances. Now to calculate the current I1, I2 or I3, either directly you can use this method or we can have some simpler method that you can just see. All these are connected in parallel. In parallel, potential difference remains same. So can you use this relation I1 into 8, it is equal to I2 into 12, it is equal to I3 into 16. We have the potential across this, and between these 2 points it will be same as between these 2 points, same as between these 2 points, because they are connected in parallel. So I1 into 8 is equal to I2 into 12 is equal to I3 into 16. So we have this relation. Now I1 plus I2 plus I3, I1 plus I2 plus I3, that is equal to how much? 78 ampere. That is already given. So now take these two equations. You will get I1 in terms of I2 or I2 in terms of I1. Substitute this, replace. Again I3 you can calculate in terms of I2. Calculate I3 in terms of I2 or in terms of I1. I2 in terms of I1. Substitute here, you will get I1. If you are replacing I2 and I3 in terms of I1. So substitute here, you will get I1. Once you get I1, using again these relation, you can calculate I2 as well as I3. So that way you can calculate. So just simplifying these two equations, you will get whatever is written here. This is all on the basis of this. Just simplify. So there is no need to remember anything. There is nothing to remember. Okay, these are just for the calculation purpose. But once you start solving, you first get into the basic, simplify and come back to the desired result. So here, they are connected in parallel. So obviously I1 into 8 it will be equal to I2 into 12 is equal to I3 into 16. Simplifying, you will get relations between I1, I2, I3. Now replace this I2 in terms of I1, I3 in terms of I1. You will get only one unknown. Simplify, you will get the value of that unknown. Once you calculate it, substitute here, you will get I2 and similarly you will get I3. Now you can see this relation. So two coils when connected in series have an equivalent resistance of 18 ohm. Two coils when connected in series, let us say it is R1 and this is R2, their equivalent is given as 18 ohm. Okay, and when connected in parallel, an equivalent resistance of 4 ohm, the same now connected in parallel. So suppose this is R1 and this is R2. So in parallel, so equivalent is 4 ohm. We have to find the resistance. This is nothing but arithmetic. So R1 plus R2, it is equal to 18 ohm. This is given. R1, R2 connected in parallel. So 1 upon R1 plus 1 upon R2, that is equivalent 1 upon R. So from here you can write R is equal to R1, R2 upon R1 plus R2. This R, it is given as 4 ohm. Okay, now we have two unknown, two equations, solve it, you will get the value of R1 as well as R2. So that's what it is done here. So simplifying, you can calculate it. Again you can see 8 cells are grouped in two series of 4 each. 8 cells are grouped in two series group of 4 each. there are total 8 cells and grouped in series, grouped in two series, group of 4 each. So 1, 2, 3, 4, 1, 2, 3, 4 are joined in parallel. So this part and this part, they are connected in parallel. Each cell has an EMF of 1.5 volt, so EMF 1.5 volt, and an internal resistance of 0.6 ohm. So R for each cell it is 0.6 ohm. Okay, the group is connected to an external resistance of 5 ohm. So it is now connected to an external. The group is connected. It means the entire part, this circuit is connected in. The group is connected to an external resistance of 5 ohms. So this entire circuit or this entire network, it is connected to this external resistance of 5 ohms. So this is 5 ohm. Calculate the current flowing in the external resistance. So we have to calculate current in this, the internal drop in the battery circuit. So we have to calculate the potential drop across this as well as this, and similarly the terminal potential difference of the battery, the internal drop in the battery circuit as well as the terminal potential difference across the EMF or the battery. So let us first start with this, the current flowing in the external resistance. So let us say it is I. Suppose the current flowing in this, suppose it is I. Okay. Now this I here, it will come to this point and it will get distributed. Now from the logic, from the common sense, we can see that 4 cells of same value, so same EMF, same internal resistance, this side and this side, they are connected in parallel. So obviously the current will equally be distributed. So suppose I1 this side and I2 this side, where I1 you can, without calculation, from the symmetry of the diagram, if the cell EMFs would have been different, internal resistance of any of the cell would have been different, then we can't say that this side I1 and this side I2 and they will be same. They will be different in that case. But here, this side it is symmetrical to this as far as the number of cells are concerned, EMFs are concerned, internal resistance is concerned. So obviously we can say I1 if it is going this side and I2 this side. So obviously in magnitude I1 and I2 it will be same. So using that concept, so again you can say I1 into how much? Equivalent of all the internal resistance here. So internal resistance equivalent to how much? 4 into 0.6. So I1 into 4 into 0.6 plus I1 this side plus this side it is I2. Up to here it is I1 and this side it is I2. So plus I2, later on we will put I1 is equal to I2. I2 into again 4 into 0.6 and that will be equal to how much? We are considering this circuit, okay, only in this circuit. So I1 into this plus this is equal to the net EMF of this circuit. So net EMF E1, because it has the tendency to release current this side, this side, this side, this side and so on. And but it has the tendency to release current this side. This cell, we don't know actually in which direction the currents are flowing, but this cell has the tendency to release current this side, this side, this side. Okay, so effective EMF this side it will be how much? Each cell EMF into 4, but so that is suppose E1. Effective EMF of this side it is, let us say E1. I am just generalizing. And effective EMF of this side, let us say it is E2. E1 is having tendency to release current to this side. E2 is having tendency to release current this side. So if it is suppose in the anti-clockwise, then it is having the clockwise tendency. Is this clear? So it means both are oppositely directed. So it will be equal to how much? E1 minus this E2. E1 minus E2. This side if you take positive, then this side it will be taken with the negative. Because if this would have been in the same direction, suppose same direction, then we could have written plus sign, but they are having tendency to release current in the two opposite direction. So we will have E1 minus this E2. Okay, so I1 into this plus I2 into this, it is equal to E1 minus this E2. Magnitude of E1 and E2 it is same. So from here you can say this will be equal to 0 because E1 is equal to E2. Now I1 is equal to I2. I1 it is equal to I2. So replacing I1 is equal to I2, let us say it is I dash. So I dash into 2.4 plus I dash into 2.4, that is equal to 0. So from there 4.8, 2.4 plus 2.4 means 4.8. So I dash into 4.8, that will be equal to how much? 0. So from there, because just one sec, I1 this side and I2, but here also we will have minus sign because I1 is coming from this side and I2 is coming from this side. So you will get this minus sign here. So this is also minus sign. So I1 into this minus I2 into this is equal to 0, means I1 is equal to I2. So from here we are only able to conclude that I1 is equal to I2. But I1 plus I2 is equal to how much? This 5 ohm. So now you will take this bigger circuit. We will take this entire of the bigger circuit, this one. So in this case, if it is suppose I1, so I1 into how much? 4 into 0.6. 4 into 0.6. Now we have taken this I2 this side. You can see this direction we have taken, this total I. So, and this I1 is also coming this side. So plus this I into how much? 5. It is equal to the total EMF of this. So the total EMF of this circuit, it will be how much? 4 times this EMF of this. So 4 times this E1. Now already we have calculated I1 is equal to I2. So I1 into this plus I. So now this I is equal to how much? I1 plus I2. Again that I2 it will be replaced by I1. So that is twice of I1. So twice of I1 here and I1 here. You can take this I1 common. So that becomes 4 into 0.6 plus 2 into 5, that is equal to 4 times E1. Simplifying this equation, we will be able to calculate the required quantity, because EMF it is already given. This E it is known to us, that is 1.4 volt, 1.5 volt. So substitute internal resistance, it is also given 0.6 ohm. Simplify and you will be able to get this I as well as I1 and I2. So I means current through this. So potential difference across this will be how much? I into 5. Current through this, that is also known. It means potential drop across each and every cell, it will be known to us. Similarly, current across this is also known, and from that you can also calculate it. So that way we can calculate all this. I hope this is clear. So always try to consider the intention here is consider the circuit equations, use the Kirchhoff's rule, develop the equations and simplify, and that will give you all the required quantity.